All right, welcome to the second video. We're going to talk about domain and range. How do you find it via graphs? So we show it right here. Say we have a graph like so, and the graph is the blue function. It's a cubic polynomial, but it ends on the left. On the right, it does keep on going down forever. So for domain, you just kind of find how far to the left does this graph go. So you just trace the graph. How far to the left does it go? All right, this is how far. What is x here? -5. How far to the right does it go? It keeps on going forever. One way that you can do it is to graph like a number line right here, right? Number line correlates to the function as well. You can see if you write it like this, it really is -5 to infinity. And you do the same thing with the range. How far down does it go? It goes down to -infinity. So that's the start of your range. How high up does the graph go? 5. Range is a little bit more tricky, and we'll show why later on. Okay? So let's kind of do some examples. Let's find the domain and range of this function right over here. We'll even zoom in because the function is that good. We want to see the function as big as possible. Okay, so what we're going to do is identify what is the furthest left it goes. So we find out it almost goes to -3, but it's an open circle. It doesn't quite go to -3. So on our papers, we write -3 is the furthest left it goes. This isn't going to work. Let's try it down over here, okay? -3 is the furthest to the left, okay? And we go back to the graph and say, okay, how far to the right can we go? This is as far to the right we can go. What's that point? When x is +1. We go over here and say +1. Because it was an open circle on the 3, that's a parenthesis. Because it was a closed circle on the 1, closed circle means it's included, that's a bracket. And again, you could also do the set of all x such that, like any set builder notation, and then plug in that inequality. -3 is less than or equal to x, which is less than or equal to +1. Oops, that's a small error. This is why people tell you not to do math in pen. But I love pens, okay? So we're doing it. Now we do the same thing for the range. And again, the range is trickier. How far down does the function go? Well, the lowest the function goes here, but it's also here. In this case, the function is at its lowest point twice. But all that matters is what is that lowest point? That lowest point is when y is -4. So you go over here and say, okay, range. -4 is the lowest point, and it is included. It does hit it. So it's going to be a bracket. Now we need to find the highest point of this function. Okay? So go back to our function and say, okay, up here it gets up to 0, and up here it gets up to 0. These are the highest points, but this one's not included. Don't worry about that then. This is not actually our highest point, because 0 is not included. This is our highest point when we actually hit 0. So we do hit 0, even though there's an open circle. Because we hit it over here, we don't have to worry about that open circle because this is bigger, okay? This is almost when y equals 0, but this is when y equals 0. And that's one of the big tricks for this, so watch out for that. So it does actually hit that 0 and our range is -4 to 0. For set builder notation, I say it always starts off this way, but you really want to be a mathematical superstar, you could start it up a little different. Range, a lot of times we use y. So you could do the set of all y such that y is between -4 and 0. And that's a little bit better. If you put x's here, it's not wrong, by the way, full points. But if you put y's, it's like full points with a smiley face. Okay. So that's our answer for example, I don't know. These are all from the book. This is example 6 from the book. Makes a lot more sense to just use the pictures that the book already has and try to write them down over here. Okay, so next we're going to move on to example 7 in the book. And it'll be very similar, okay? Let's scroll down and find it. Again, by the way, the book does have like solutions to all of this if you want to really see this. Oh, no, don't do this to me, book. Okay, the book is wrong on this problem. This is not making the point I'm trying to make. Don't look at the solution for that one. Look at my solution for that one. I'll have to submit an error reporting form. Again, this is open source book. So, you know, when you pay $300 for a math textbook, they can put in a little bit more work to find errors, especially when it's the 15th edition or whatever nonsense. This one, as I find errors, I do report them so that you can get that fixed in the future. But yeah, anyway, let's go to example 7. Oh, this one looks interesting. And that's mock surprise. I'm not seeing this for the first time right now. I'm reacting how you may react. So find the domain and range from this graph that models oil production, okay? With the year as the x-axis and the actual thousands of barrels produced per day as the y-axis. So we just do the same thing for domain. What's the furthest left we go? Kind of hard to see, right? We have 5-year blocks. Maybe this is 2 years. Why? All right, this is a kind of a, I don't think this is the best created graph. Yeah, it looks to be about 2/5 of that year, 1973. Does it really not tell us? Yeah, looks to be about 1973. Okay, so we go over here and say for our domain for this one, we start at 1973, and we have data there, so that's included with the bracket. Then we go back to this graph and say, okay, how far to the right can we go? And we have data up until about here, 2008, I'd say. Is a little bit bigger of a gap than this. 2008 or so. Okay. As a side note, in situations like this, right, where it's not very clear what x coordinate this is, if you said 2007, I'm not going to mark off points, okay? That being said, I will also try to always give you graphs that are very clear and have the information I want you to be able to use. Being able to interpret unclear graphs is an important skill, but it's not a skill that I'm trying to teach or test you right now, okay? And that's all we do for the domain. So for the range, we do something similar. We see how far down we go. What's the lowest point on this graph? Maybe right here. It's a little bit under 200. If you want to guess 200, you can. If you want to guess 190, you can. I'm going to say, in my infinite knowledge, that we get 190,000 barrels per day as our lowest point. And then we go up to the top. It's a little bit over 2,000. Let's say 2,100. Why not? That's the biggest we get, which is about 2.1 million barrels. Because again, these units are in the thousands of barrels per day. So 2,000 thousands is 2 million. Right, and that's all you do for this one. Okay, just find the lowest, find the highest, find the furthest left, find the furthest right. Okay, last one before we talk a little bit about toolkit functions. We got another graph with world population increase, and this one is much clearer. Okay, so domain is furthest left. This is try it number 6. So if you want to be a mathematical superstar, you'll pause the video right now, try it yourself, and then we'll see if my answer matches yours. So go ahead and pause me, because I know all of you are superstars out there. Pause the video. All right, you have now unpaused it, and we're going to talk about this. So domain, furthest to the left. How far to the left we go? Right here. What's the x coordinate? Again, domain is x's. So furthest left, we care about x coordinates here. We don't care about the y coordinate here. Actually, we will later, but that's sort of a coincidence. The furthest x coordinate to the left is 1950. Okay? So the furthest we get is 1950, and that is included. There's no open circle here or anything. Now, how far to the right do we go? So we go on a little journey. It's a little bumpy. And this is the furthest right. What's the x coordinate there? It's 2000. So that is our furthest x coordinate. That's our domain. This graph has the data from 1950 all the way up till 2000. Okay. We do something similar for the range as well. So what is the lowest point on this graph? This is the lowest point on the graph. For range, we care about y values. This is maybe 46. Again, kind of estimating a little bit. Like 46 million people is the lowest we can ever get in Sorry, I'm a little I didn't actually look at the context. World population increase 46 million. I don't know exactly what that metric is. There's a little bit of missing information and context on this data. Anyway, and what is the highest point? And this is not the highest point. This is the furthest to the right. We care about the actual highest point for the range, which is up here, which is about 90 million. Okay, so we'll write 90 right here. As a side note, if you wrote 90 million instead of 90, that would also be correct. It's not exactly clear over here whether it wants your units in millions of people, in which case 90 is correct, or actual people, in which case 90 million is correct. I'll be a little bit flexible and try to be very clear if I ever do have a preference. Okay? That's the gist of domain and range from graphs. If you feel good, you can go ahead and start working on the homework. But if you're worried about future sections, the toolkit functions are coming back. Okay? Remember I said in the previous section, toolkit functions, we're going to use them all chapter long. And they're really going to be big later on in the chapter. This is not when they're big yet, but if you want to get more familiar with them, now's the perfect time to do it. So this is our constant function. Domain, x is far to the left. We can go off to negative infinity. To the right, we can go off to negative infinity. Our domain here is any number. We have all the x's covered here. But our range is a different story, right? The lowest this function can go is c. The highest this function can go is it doesn't go up or down, right? The only y value is just c. So we say that the domain is all real numbers, but the range is just c to c. This is a very small interval, okay? Infinitely small, actually. What was another identity function? We can go as far to the left as we want, as far to the right. We can go as far down as we want. We can go as far up we want. That's going to have all real numbers for both the domain and range. The absolute value function, we talked about the domain a little bit before. We can go as far left and as far right as we want, everything in between. Domain's all real numbers. But the range is not all real numbers, right? Because the furthest down we can go, the y value here is 0. Y value will never get lower than 0. But again, we can go as high up as we want. So the range is actually just going to be the interval from 0 to infinity, like so. Okay. Same exact case for a parabola. It's a different shape, but it has the same domain and range. We can never get below 0. Cubic function, going to be all real numbers on both. Because we can go as far as we want to the left, as far as we want to the right, as far down as we want, and as far up as we want. All real numbers on both of those. Ooh, the reciprocal function. This is going to be something a little different. We can go as far left as we want. We can go as far right as we want. But not everything in between. We cannot plug in x into this function. There is no function value when x is 0. We have an asymptote at x equals 0. So the domain is going to be everything except 0 here. Similarly, the range is the exact same thing. The y values can be any y value except for 0. We will never have an x coordinate of 0 or a y coordinate of 0 for this function. That's our domain and range here. Everything except for 0. Again, remember you can split that up with that union sign. Similar for the reciprocal squared function. Any x except for 0 works. This time we don't have any negatives at all for the y's. The y still can't be 0. It also can't be negative. Our y values are only going to be strictly positive numbers, 0 to infinity with a parenthesis. Like so. Square root function. X can be 0, that's okay. And x can be any positive number. X can't be anything negative. We'll have 0 to infinity inclusive. And the same for y, right? Furthest down we can go is 0. Furthest up we can go is as far as we want. We get 0 to infinity for both of these. This is going to be all real numbers. Again, we can do any x and any y for the cubed root function. And those are our toolkit functions. You really are going to eventually need to become very familiar with these functions. Okay? So if you're still not familiar with these functions, what I'd do is I'd open the textbook. This is just from the lecture portion of the textbook. Go through all of these. Don't spoil it for yourself. Stop the window right here and find the domain and range. Get more familiar with what these functions look like, okay? It'll help you out later.